So in this section, we are going to talk about the security features. So like in the last class, we have discussed about IPv6 first hop security. So now like there is something, we have this IPv6 RA Guard, which we will see in this section. So we'll try to understand what is this IPv6 RA Guard and what is the use of this RA Guard. So if you remember in the last section, we have discussed that there are two more types of messages which we need to understand. The first type of message we have seen was your some router solicitation message. So I'll be writing here. The first message was your router solicitation message. So this router solicitation message is always generated by, like we can say, some any host to identify the gateway. And we have seen some router advertisement. So this advertisement is something when the router receives the router advertisement, it's going to reply back. So we can say about this router solicitation message that it is generated by any host. So we can say generated by the host machine, or we can say by the client machines to identify their gateway. Like what's the gateway inside the network, and this router advertisement is something the reply of this we can say that is like the reply of this router solicitation. So when the router is going to reply, that's what we have here in this, like we have your router advertisement. So these are two types of messages, router solicitation and router advertisement. Now basically, like if you will go back to the previous configurations of IPv6 router advertisement guards, and like we have seen some preventions and attacks. So basically, like if you will see that in the basic IPv6 layer 2 option, we have seen that router solicitation message is always initiated by the router, right? So basically asking the information about the local routers that this message is sent on the, we can say, on the LAN segment, and then the router solicitation message, it is going to say that whichever the router is going to reply back or advertise, then it's going to be considered as your router advertisement message. So we can say that in that kind of scenario, there can be attacks inside your network. For example, we can, let's have a scenario like, let's say you are having a wide area network in here and you are connected to your internet using your router. So this is your production router, and here on this production router, you got one switch. So let's say this is your switch. And then this switch is connected to multiple users in here like this. Now there is one more, let's say there is one kind of attacker or one person in the middle who connected his own device, and we are assuming that this person is your attacker in here. So in these kind of scenario, the like there can be attacks in your network where might be some attacker who is trying to advertise himself as a router. So let's say when the clients will request for the like the clients will generate the router solicitation message, then the router will reply back. But in here we got this attacker in between. Now this attacker, we will say that I am the router. It's like attacker is pretending himself as a router. But like we know that this is not a valid router, but as it is acting as a router, so it can reply with router advertisements. So once it is going to reply back with the router advertisements, these PCs are going to think that this is something like we are going to have this as our gateway. Now, whatever the information which has to be passed via like this will go from this attacker, and then from this attacker like this. So this is how the flow of the packet will be if in case like this attacker advertise the router advertisement, advertising himself as a valid router in reply of your solicitation message. So now this is something, what generally happens in here. So we call this scenario as, we can say, some router advertising spoofing attacks. We can say router advertisement spoofing attack. So this is what we got in here about the devices. Like these are the attacks which generally happens. Now, this is this we can consider it as your man in middle attack here. So to overcome this, we have the feature of router advertisement guard. So basically this router advertisement guard, it is a feature, like let me write the point. When we talk about the router advertisement guard, so this RA guard is a feature which is going to prevent the router advertisement, to prevent the router advertisements and spoofing attacks. So we can say this is what it is going to help us out. this RA Guard with this kind of to prevent these kind of spoofing attacks, and it can also block unauthorized router advertisements. So let's say, as per this scenario, like you can see, we have discussed the things here on this lab topology. So in this lab, like we'll see some lab scenario, like what exactly we are going to do is like, the clients are going to generate the router advertisement mess, like the routers will generate the router advertisement messages. So we will tell the switch to keep monitoring the router advertisements, because router advertisements are generated by the routers. So assuming that this attacker is also your router, so it can also generate the router advertisement, but we will tell the switch that you need to monitor the router advertisement, and if anything is coming from the router, like from this router interface, anything coming over here, so we can say that this is trusted. And apart from that, if anything is coming from other switches, that will be untrusted. So if a switch is going to say, let's say on the trusted interface, like this is, I'm going to assume that this is my trusted interface and rest other interfaces are my untrusted interface. So I'll say that if my like the router advertisements are being received on the trusted interface, then they have to pass through the network. Else, if I am receiving any kind of router advertisement from any host machine, so like you need to discard the packet, or if any other port is just sending the router advertisement apart from this trusted interface, so that means we are going to discard this specific port. So how basically it's all done. So let's see a quick lab scenario that we are going to configure. So just let me share my lab screen. So I got this topology in here. Now in this topology, the first thing we are going to do is like we are going to let's say we are going to create some trusted interface and we are going to create some untrusted interface. So for example, right now, as you all can see that on this in this topology, I got two PCs. Like we will be assuming that this is my client PC, and this VPC3, I'm going to assume that this is something we can say that some user who is trying to pretend that it is acting himself as a router. So what we can do is we need to tell the switch to keep the interfaces up, and like from where you have to allow the router advertisement and from where you have to deny. So mostly in IPv6 security configurations, like when it comes to first hop security configurations. So in case of first hop security configuration, which is like based on some policies, and we need to define something like neighbor discovery, router guard, router advertisement guard, and like we have some trusted and untrusted policies, and we have some device rules. So which we are going to see how exactly it's going to happen. So here, if you'll go on the VIOS one, so as you can see, nothing is up in here. So on VIOS one, I'm not doing anything, just I'm configuring some policies in here. So I'll go and here on the switch, I'll tell this switch that first of all, I'm going to define some policies here. So let's say I'll go on the global configuration mode. And the first thing I'm going to do is I'll say IPv6 neighbor discovery RA guard, and then I'll say the policy. So if you'll put question mark, so it is now asking for the name of the policy. So first of all, I'll define the policy as untrusted. So I got one untrusted policy. So now you can see I have defined I am in the router advertisement garden here. Now I will see that the device role. So I need to define the device role. Now device role, if you'll put question mark here, host, monitor, switch, router. So I'm defining this untrusted policy for the host that no host machine can generate any router advertisement. Now once this is done, we are going to select the interface, let's say this gig01 and this gig02, and we will tell these interfaces that you are not allowed to generate any kind of we can say some router advertisements. So here in our scenario, I'm going to say that interface gig 0 by 1. So this gig 0 by 1, and I'll select it. I'll say IPv6 ND neighbor discovery RA guard. And after RA guard, we need to say attach policy, and which policy you want to attach. The policy which you created was untrusted. So we have attached this policy, and the same thing we are going to configure it for the trusted interface. So this was for the host machines. Now I will go and I'll create one more policy. I'll say IPv6 ND guard, RA guard, and I'll say trusted. So this is my trusted policy. Now on this trusted policy, I'm going to say the device role, that this trusted policy, I'm defining it for my device, which is my router. Now I have defined it for the router. Now the router interface, I got gig00, which is toward my router. Now gig00, I'll say the same thing, IPv6 ND guard, and I'll say attach policy. And here the policy I have attached is the trusted policy which I have created. So, okay, IPv6 ND guard, RA guard attach policy. So, we got some hardware failure in here. Okay, no issues. Meanwhile, this is how the command we are going to write in here, and we got some hardware failure in here. But if you will see that I need to verify like what are the policies which I have configured. So you'll use show IPv6 ND and you'll write RA guard. And once RA guard is there, then you will see the policy, and if you'll put question mark, so you can see like you need to write the policy. So let's try to verify the trusted policy which we created. So you can see the trusted policy is there, but as of now it was not assigned. So I'll try to verify the untrusted policy. So you can see the untrusted policy I have defined as the RA guard in here, and we can see that this gig01 is now my untrusted port and it is protected by the RA guard. So no router advertisements will be sent in case of this scenario. So like there will be no unnecessary, unnecessary router advertisements which are sent by some invalid router, which will basically disturb your network or which can create some kind of man in middle attacks. So this is what we are going to do. So this is this whole soul command syntax which we have seen in here. Now, the next thing when it comes to this kind of configuration, so you can try the same lab with using the policy command and defining the device roles. So once this is done, that's all you have to do as for the verification, and then rest in the upcoming sessions, we will see like how it's all done and how basically it's going to we will see like how the DHCP configurations are there, and apart from that we will also verify the messages and the output of messages in the upcoming sections. So this is how basically you need to configure the IPv6 RA guard, which is basically a part of your IPv6 first hop security. And there can be many things like, there can be many policies applied for these specific ports as well. Like for example, we can do one thing like we can apply a VLAN 10 and we can put all the host machines inside the VLAN 10, and then we can assign the VLAN 10 with the policy that this is some untrusted policy. We are defining it for all the host machines that they are not going to generate the router advertisement. So this is what we have in here about the first hop security. So that is the part of IPv6 introduction. We can say we have covered so many things as of now, like from starting from the neighbor discovery, and we have covered the first hop security as well. Now in the upcoming videos, we'll talk about the DHCP configurations with IPv6, and we'll see some configurations and debug outputs, like how all these messages are generated and how the solicit message is generated, how this neighbor advertisement is generated, and all that part like we will see in the upcoming sections. So this is all for this first hop security.